Hello people. So this is now it's about number 4 in the series. I think it is 4 or 5. What's this one? So we've already got the PWM fan working. So next we need to get it working using a thermistor, which yeah, it's looking a little bit beat up, but hey, it'll be okay. I've got a few more. This is just testing that kind of thing. And if you notice a blister on my finger, careful what you're doing with soldering knives. Yeah. So how we're going to do this? Well, to be honest, I've been digging around on the old hive mind, also known as tinterwebs. Got a pretty nice sketch actually. I've kept it nice and small, which is ideal, which is what I want. And my plan is to just quickly go through a bit. What we're going to do is we're going to be using a voltage divider. I'm not going to go into the ins and outs of a voltage divider because you've got the Google Hive Mind out there as to how to do it. So this is just how to build it on a piece of breadboard and looking a little bit on the nasty side. So our reference pin, the pin that we're interested in, is the center one. Okay, and we're going to put that into analog 0. We're going to use a reference pin, and we're going to use 3.3 volts. Apparently 3.3 volts is a bit quieter, so we want to connect them two together, and then we'll take that and put it up to one side of our thermistor. Okay, and so what we're doing now is to make the divider complete is ground into that side. Don't do what I did. So you can see how they're in line. What I was doing, I've just spent about 20 minutes trying to fault find, when what I'd actually done is, like a prat, I'd put the this was actually the ground. I'll put it in the next column along, so I wasn't getting the connection. I was going bonkers. Yeah, anyway, so that's it. So get on, open up your IDE, whatever IDE it is you decide to use, or hardcore system or whatever. Upload, and I haven't figured out how to screen share and that kind of stuff yet, so I'll get around to it. But as I say, this just works straight off the bat. Now, in the code, when you look at the code, you'll notice that there's lines that can change it to Fahrenheit. If you're more comfortable in Fahrenheit, I'll leave that in there in the sketch so that you can change it. And to test it, you simply put your fingers on it, and you should get up to 30, 31, 32 degrees. Mine has gone up to 31. Yeah, it works perfect. What more can you want? I've got a damp sponge here, so I'll just put the damp sponge on and see what happens there. So that's on 27 currently, 26. Quite slow to come down. Well, that's me lot there. 25. Yeah, it is coming down slowly. But it'd be nice to get some better, some more positive actual temperature readings. Which, as it happens, this here, this is, ouch, that's quite hot. This is my controller for my fans. So you can hear the fans spin up. Yeah, so I just do that. Just LM317. Yeah, it's nasty. So actually, what I'm going to do is, yeah, I might do this properly, you know, so I can actually get a temperature on that. In fact, yeah, I'm going to wire that up now. I've got some, yeah, there we have some heatsink paste. So I'm going to plaster that onto there. That's really cool. Right, back shortly. Hey guys, so if you could please excuse this unorthodox method. Basically I'm having problems with screen capture and I want to show you this. So as I say, this will be linked below. All the code that I'm going to use and all the sketches will be linked below, so there's no worries there. What we've got here is, if I can sit the camera down, let's just say that didn't go amazingly well. So you should be able to see that nice and clearly. As you can see, temperature at the moment is 39 degrees. And what I'm going to do now is I'm going to turn the fan speed down, which will affect it. And the reason that it's going to affect it is because it's having to sink more current. through the LM317. As you can see, the temperature's going up. The fans are barely turning now, so it's having to sink a lot of current there, and we'll see that rise quite rapidly. And I think that's proven, it will prove that this is actually quite a successful test and will do exactly what I want. So there we're up to 42, and that will slowly go up. I was expecting to go a bit quicker, so it was 43. And you can see what's going to happen as it's sinking more current. It's just going to keep on increasing in value, which is exactly what we're needing. So once that's what's got an NTC plastered onto the just the plaster, by the way, is there silicon heatsink plaster. Very handy stuff. It's always worth bearing in mind that once it's open, try and use it, because as I've just found out, you get a nasty crust on it. So this time, next time I open one, is I'm going to store it that way, in that rotation. So then hopefully the front end, I won't get the blockage, but I don't know. So we'll just have to wait and see. Now you're going to see 46 degrees, 47. Well, it's probably on 46.5 or just over 46.5, and it's rounding up. And as it's wavering in that area, there we go. And so now it's definitely over. And it'll just keep on rising and rising and rising while the fans are going slow. And if we go back, so and there is the circuit. Again, we'll go through it again. These two just connect onto the thermistor. So we're using it as a voltage divider. The center tap, for want of a better way of putting it, goes into A0, AREF, and 3.3 volts connected together, which is then in turn connected to one side of the thermistor. The other side of the thermistor is connected to the resistor, which then goes through to ground. So that's where you got your voltage divider, and that's how the Arduino can figure out exactly what the value of the thermistor is, and work it out that way. So hopefully you'll find that useful, and I'll speak to you soon.